Robots that see like humans. That's the promise of a new collaboration between CynLr, a Bengaluru-based robotics startup, and the Indian Institute of Science. Together, they're trying to crack one of robotics' hardest problems, giving machines the power of biological vision. If successful, it could change how factories, warehouses, and even universal manufacturing lines work. We spoke to Gokul, the founder of CynLr Robotics, to understand what this means. But beyond this one partnership lies a bigger question. Where does India really stand in the global robotics race? On this episode of Point Break, we dive into the IISc CynLr collaboration and what it means for the future of Indian robotics. Let's get into it. Yeah, so hello, good evening, Gokul. It's very nice to see you again and welcome to Point Break.
Pleasure to always talk to you. No, thank you. Thanks for the opportunity.
Yeah, thanks, Gokul. So today I'm touch basing with you to understand the new collaboration announcement that came out between CynLr Robotics and IISc. So can you tell me what the collaboration is about? Why IISc and why now?
So, the collaboration is largely about the missing gaps that we have in understanding how human beings are able to learn on the fly. Today, machine learning cannot learn on the fly. You have to pre-train large data sets and so on and so forth. But yet a human being is able to instantaneously use his faculty to learn and correct or recover from the mistakes and so on and so forth. If he's not able to complete a simple task like picking apart or manipulating things. What also seems to be that, I think in the past also we have explained that we always take our algorithms from the brain, human brain, how it actually works. And there are a lot of dark regions that we do not know about how brain actually functions about it. The neural network today is at best is a very simplified assumption of how brain may be working. We do not know that this is how the brain actually works and what it actually does. And its gaps are often felt when we have to make robots do something more meaningfully. Though you see a lot of YouTube videos, Boston Dynamics also showed a lot of YouTube videos. The things beyond that, when you have to go and deploy into a customer's place, there are a lot of scenarios that you couldn't have pre-trained or designed in your mind for an engineer couldn't have tackled all of those situations. So we need to equip the system to be able to figure its answers by itself in that place, right? So if I asked to go and pick a pen and a cap and then put it together, but the cap fell down, it should know what to do. And I had to go search how to kind of pick them from, how to recover from the situation, then come back to the taught task, right? Nothing very fancy, nothing very complicated, right? Simple thing, if I'm putting a screw into a screw hole, if you feel that it is actually getting misthreaded, then I need to know how to kind of correct myself back and then bring it back to the normal, bolting action. It's a very, very trivial thing for a human being. But that's also because we don't understand how much of brain processing is happening, because all these are unconscious. It's involuntary for us. So we don't dictate and design and plan these things consciously. The body does it by itself in many cases. So that layer seems to be very, very large, and it's completely unknown how the brain goes about doing it. Like I always articulate, even the process of how vision evolves in our head. Eyes give you sight, but the process of understanding the real world, what that bunch of colors mean in terms of, like I show you a picture of mango, mouth waters, right? So how do I associate a bunch of color to the taste? Yeah. How do I associate that to what it can feel in my hand? How much weight it could be? All those anticipation that you bring about, that's vision. That process of taking that abstract information from the real world and converting into a meaningful task goals for you is something that is completely unknown. So that's the process that we want to kind of learn more, research into, and then see how human beings are able to do that and what portions of your brain is doing that and how is it doing it. And so that we could just replicate it back into the robots. And for the customers, it will manifest as the ability to a robot that they get, which can figure out its task in real time and learn in real time, right in that scene. Instead of, oh, whenever it fails, then take the failure image, take it back to your machine learning system, train that again, wait for a couple of days, and then come back. Meanwhile, your line is just stalled. It's not operating, right? So you don't have that situation. So.
Mm-hmm. Yeah. So with this collab, what are you looking to achieve? I mean, that's what. So how is IISc kind of helping with this whole thing?
So IISc's neuroscience lab is specialized in doing this, and so they will segment into three kinds of engagements. One, they will help us understand the brain more. So in that, we break into two aspects. One, what we call as the functional behavior of the brain and different layers of your neurons and the brain layers in your head. The other is anatomical. What we say is, how does each of the neuron function? So today we have an assumption in machine learning that all neurons are very simple, y is equal to mx plus c, linear machines. It's a simple one type of equation for everything. But actually your neurons seem to have different types of equations. Each neuron seems to have function very differently. So all that we have to kind of study. So those study, they are equipped to do that on tapping the brain signals and then from monkeys, and then kind of analyze those recorded brain signals and interpret patterns of how brain may work. So this is predominantly like as a research engagement, a full-fledged research, sponsored research that we are doing with IISc, and it will have an involvement of PhDs and postdocs along with the professor. And eventually, we also look forward this to translate a pipeline of talent pool for CynLr 2 to bring in our internal neuroscience and machine learning team through that engagement. And IISc also is notably, this lab is also one of the global standard of labs that we have. And we also look forward in the future to stitch a project between other universities. Like we also have engagements with EPFL, and we also look forward to do more in university engagements. So all the fundamental research could be stitched together into a format of project that makes more sense. Today's the research towards this problem is very fragmented in applying to this robotics. So we want to stitch them together into a very coherent research and focus towards making robots more intuitive by themselves to be able to pick and place objects and so on. So to focus towards that is where we are driving this collaboration with IISc also.
Got it. Okay. And I think when we last spoke, maybe I think a couple of years ago, we were talking about this whole data piece for robotics, like the whole integration of the data bit, the data training. That was obviously a challenge. Do you think in the last 2 years we have progressed way more than, what we were looking at?
I think the supply chain has progressed more.
Okay.
And
so this still remains a challenge.
This still remains a challenge. In both fronts. One, so first of all, we are obsessed over data. We should be obsessed over signals. These systems, the difference is data is when you have recorded the signal. The data could be what you're writing in a paper. You observed something that is happening and you wrote it in your paper, that becomes the data. So anything that you have recorded becomes the data. Whereas the reality happens in a continuous time space. So first of all, the kind of information that you're collecting itself is poor. Second, the focus has been probably on making the gait movements, making it move like a human being, do things like a human, act like a human being, but not perform like a human being. Right? To be so there is very less emphasis on the sensor combinations that you need to put. So human beings are less equipped with freedom, but more equipped with sensors. The whole volume of sensors, because that's where the data will come from. Sensors is the provider of the data, and that's the one that interprets the real world signals into data for you. So all those mediums that can convert all the real world forces and signals and energy into your data for you is largely a gap and missing, both from a hardware layer. Because hardware is missing, then obviously it's missing in your data layer. Since it is missing in the data layer, it's not also manifesting into your machine learning models. So that gap is still there. But what it has happened in the last 2 years is, before we also had a difficulty of the hardware spectrum being very narrow. You didn't have an ecosystem. There's no supply chain. So all that is now, there is an industry that is fostering right under this topic of robotics now, and industrial robotic arms, because of humanoids and so on and so forth. Because of which motors purpose built for robotic arms are coming up now. Like how after EV happened, battery innovation has happened more. Similarly, because of humanoids, most of this infrastructure is getting more mature. and they're willing to build that more. So that is helpful. And more active research is going into grasping, more active research is going into these skin kind of sensors and so on and so forth. That has improved. But I think this data problem will start getting fixed maybe few years, couple of years down the line, because the infrastructure needed to build the data is only now is coming up. And many of them are starting with, oh, this much data is enough. Just an image sensors data is enough, depth is enough. So there are presumptions that are getting broken much faster, and the collective learning of the industry is growing very, very high. So that progress is going to happen, and that I think is few years. It's going in that trajectory, but it's not yet there yet.
Okay, because see, as an outside person, when you look at the developments in robotics, by looking at the demos, you spoke about Boston Dynamics and the Helix robot. I mean, you kind of feel that okay, we're there. I mean, we're like right there. And I think recently even Nvidia launched the Jetson Thor for $2,500. So what does all this mean? I mean, so you're like you said, it does not mean that everything is just very nice and glorified and it's like right there.
I think the foundations are forming, but I think it's hyped. There's a lot of hype to bite. It has always been exciting, by the way, right? So the form factor of this humanoid is 1935, 6, somewhere around that time. First movie with that Android form factor actually comes, right? It's that old, essentially. If you actually see the videos of, there is one video of Unimate. That's the first robotic arm, industrial arm that was built 1956, 57, maybe around that date. You can just YouTube it. Whatever that we are showing here is, oh, it'll pick the Coke bottle, it'll open the Coke bottle, serve a person. It's exactly the same video that they showed in 1956.
Wow.
Right?
Okay,
Nothing has changed. Right? Whatever that we are doing also, right? So the way that the robot is able to go and pick an object using a visual camera. There is a Stanford lab video in 1970s, right? With analog camera.
This is doing that.
Yeah. So when you are there, when the engineer who built it there, it working is very different. When the user have to pick it and then make it work, it's a very different problem. So it has always been working in the hands of an engineer. It never worked without the engineer being there. So basically you're operating them. And many of these are like remote operated. They are not like
autonomously functioning on its own.
Not autonomously functioning enough. And there are very narrow cases, narrow cases in which it's been demonstrated. The demonstration is getting more vivid.
Absolutely.
It is not getting into a real world proof yet. That is true for us. That is true for everybody, frankly, to be said. Right? But the world needs to not bite into it and then start. There are a lot of companies that are foundationally building. They are not being talked about. The sexy ones are the ones which actually capture the mind space a lot more and media space a lot more. And that's an unfair thing. That also routes a lot of investments towards them. But there are a lot of foundational companies which are building very first principle groundwork that they're doing. Unfortunately, they don't get highlighted. The market has always been there. The financial market failed to see it. And the conditions and cases are more ripe now, with the labor costs going above the technology costs now. And those conditions are very, 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 very ripe now. I think the financial market should start investing more into the supply chain for it than in the foundation building blocks for it than the humanoid form factor more. They're more form factor focused than the foundations that are actually coming under them. That is what I would say that the world must, divert its attention towards.
Understood. And brings me to the next question of then the talent bit of like you said, of course, there's still a long way to go. So now with, say, like you said, you have collaborated with universities, we're collaborating with IISc. Do you see, talent is not a problem, right? Or do you see that, say, the great talent that you need still remains outside India?
Talent is an immense problem.
Yeah. Okay.
Talent is an immense problem globally also for this domain. Because this is a non-existing industry. It's an industry yet to be built. It's a category creation altogether, right? So it doesn't exist and it's a paradigm shift altogether, right? So which means the tools that are needed for you to build the company, not just the talent, even the processes, the supply chain, the services network, tools to operate those processes. Like for software, you have Agile and you have Jira and all these, whole trail of suite and DevOps and all this layers and platforms, SaaS, all this is actually there. And how to operate, how to do a project management around this, how to do a engineering management around this, all this is none of that know-hows, business know-hows are available for us. And we can't borrow from an other industry because that is built to deliver software at the end of the day. It is not built to deliver. And then you will always, if you follow this process, you will end up pivoting towards software because that's what works for you. That's what the process can give you as an outcome. So you have to discover that entirely from scratch, which means both on the business side, business and thought leadership side, and also from the talent, technical talent side, there is a gap. And this is one discipline like none other before. We have every discipline of, this is one industry where every discipline of engineering has to come together. And all of them bring a very different set of tools and practices that have never worked in tandem before, in a way. And they don't like the CAD software and then being a project management, one project management tool that will help me to have a CAD development or a getting a fabricated piece of metal along with my R&D research that I'm doing on neuroscience, along with that to my programming, managing them all together. You don't have a tool. All the data flowing between each other, you don't have a tool. You don't have a format, first of all, to data to contain, right? So you don't have one language for us to kind of program with and so on. So there is a lot of gaps within this. This is one side. If the industry is this nascent, I can't expect the industry to supply a talent also for me because the skills don't exist today. That's one. And the interest to work on this, even though there's a lot of hype, that is not mirroring so much in the market, even in India. Still, there is a salary chasing that happens, and then and things. Somewhere in the talent space, there is some level of sanity. Sanity is proof of money and proof of career, right? If you don't have that, then it's harder. The other problem is people who are very research savvy and research oriented, retaining them in India is very complicated. The level of UG maturity that they have achieved and the standards that they've achieved in UG, like IITs and so on and so forth, how many institutions like IISc or TIFR are there in India? Right? What is the recognition in global landscape for if someone has passed out of an MS and PhD out of these places? This can happen only if we bring in professors from other universities and then pay for them to bring the MIT professors, Stanford professors, have that value, because that's where the recognition comes from. And the companies will start recognizing them, right? And there will be a career space that will come. Some of you are averse to bringing them in here. And that extra expenses has to come, right? So much so UG colleges are not proud of the fact that these many MS programs that they offered and these many people have enrolled into it and these many people got hired for so and so with an enhanced salary. They are proud of what these many people went into these US universities. These many people will go into European universities. That's what their statements of claim is. The metrics have actually come down very differently, right? So this also fosters a different kind of, or grooms a different kind of mindset within the young talent, right? So one, I'm not able to borrow the experienced talent. The other side, I'm also constrained with retaining fresher talent also, right? So I spend more than a month personally, 8 hours every day, inducting them and then walking them through the whole technology and then all the technology layers and teaching them and everything. Right. Neither does university groom them from those fundamentals either, right? So I'm not talking about machine learning training and so on and so forth. At the cost of machine learning, most of the universities have scrapped a lot of these foundational university courses or fundamentals, basically, like control systems, and which are the foundations for you to even, if you want to build ML models, if you want to apply ML models, whatever that they have as coursework now is okay. But if you want to build ML models from scratch, the coursework that they have is not helpful at all. They have no idea what happens under the wrapper, right? And think from the math, think from the foundations of it. None of that is possible. So a lot of these gaps largely there is existing, one, and the other, even within this talent, I also have to build a supply chain for myself, which means I have to reinvent every component that goes into my robot system. It's pretty much like I'm trying to build a car using cycle wheels. I need to have a wheel that is meant for the car. Otherwise it'll never see the light of the day. For me to do that, it's a very different process. It looks round. That's when the analogy stops. Everything else for what you do for a car wheel is very different from what you do for a cycle wheel, right? So all that foundational research and somebody who can build that is very concentrated towards Europe. Not even US. It's very largely concentrated towards Europe. So that's another reason that we have to be like, we have this famous saying of the world is made in China, but the China is actually designed in Europe. All the machinery that China uses to produce the items of the world was all built in Europe and then designed in Europe, right? So that reminiscence of the talent is still there in Europe, and then that's a necessity for building this product that we have. So I have to go and then interface with those places. Yeah.
So despite all this, Gokul remains committed to being in the robotic arm and the whole chase of making it. Which brings me to the next question of, I know you've also been doing well.
So, sorry.
I know you are 100%, more than 100 probably. But the question of how, not the question, I mean, I've also been following your work. You've also expanded to Europe. Like you said, Europe is also the hub. So can you tell me about any recent developments? So what is CynLr out to achieve, and how is it going so far?
So there are some aspects that have come from a recognition point of view, and plus we have opened up more customers now. Audi is part of our customers. You will see the doors assembly here, and we are looking to onboard a few more customers. Also, we have a good pipeline within the Europe space, more than US. Now we also have opened up one more office in Texas, Austin, in US. My partner Nikhil has moved there for GTM expansion and also to customers and sales. And also we'll look at investments from Silicon Valley from the front. So what we're trying to do now is to convert these order into the pipeline into full-fledged deployments for us. But that will consume more investments and infrastructure development for us. We have expanded. I think last time when we met, we were like 30 plus engineers at the time. So now we are like 65. We'll be soon crossing 80 plus in the number of engineers. But we will freeze somewhere there. The current capacity is something we can't scale beyond 1.5 million to 2. And we might hit that this year in terms of revenue. And we will freeze there. We don't have capacity to address more than that now. And we'll use that as an indicator and a validator, market validator for us to kind of raise further rounds to fund expansion and capacity building within the organization for us to scale more. Our goal is to kind of have a proof of break even in 2027 to 28 in that year span. And that should consume close to around $40 plus million for us to get there. And then we could actually do in terms of capex, and an operational break even should happen somewhere between $30 plus million to $30 to $40 million for us and with them. And that is for us is a model proof, business model proof. And then we will double down our investments into exponential scales post which. So that's an underlying principle on which you're working right now.
Got it. And is automotive the sector that you prioritize?
We are sector agnostic. Anywhere object manipulation is needed, we could go. But automotive as a customer is more mature to absorb at a nascent tech. So any deep tech scenario is product maturity takes a longer period of time. And you need a customer to reflect on the technology for it to become a product, right? And the capacity, somebody who's capacitated with engineers in-house, with processes. See, they have been profitable with a dumber robotic arm, which was nothing but 3 pipes and 6 motors, right? And they could actually make that work for them. And so they have the capacity. Other industries do not have that maturity or a process around them. Neither the infrastructure people or know-how or process around them to kind of make this happen. So that is where there is a bias towards automotive more. Incidentally, we also have, we'll be onboarding soon a semiconductor company. One of the largest players in semiconductor, special purpose machine builder for semiconductor fabrication and things. So we are doing one assembly task for them, and this month we will get the PO from them. So that's another massive inroads for us into that industry. But that's not where the thing actually stops. But these are companies that are equipped to handle and then convert this into a successful solution for themselves. And we will build further with them as a reference, application reference for the rest of the other customers.
Yeah, sounds exciting. A lot of things happening. Anyway, thank you so much, Gokul, for your time.
Thank
Truly
you.
insightful.
Thanks,
Always a pleasure talking.
Chandra, for this. Always a pleasure. Yeah. Thank you. Have
Thank
a
you.
good day.
The IISc CynLr partnership isn't just about one breakthrough. It's about pushing Indian robotics closer to solving universal problems of vision and manipulation. As Gokul explained, the goal is to build machines that can adapt like humans, opening doors to the idea of universal factories. India's robotics story is still in its early chapters, but collaborations like this show the ambition and potential on the horizon. That's all for this episode of Point Break. I'll be back with more insights shaping India's robotics revolution. Until then, stay sharp, stay curious, and think AI, think AIM.